Running your own AI infrastructure doesn't require becoming a cypherpunk. Recent research from Own Your Mind shows that building a sovereign AI stack has become a practical engineering decision for any operation scaling past a specific volume. Centralized providers offer frictionless access to models, but that convenience carries hidden costs. You surrender privacy over your data, face unpredictable censorship, and hit a wall of exponential API fees as you grow. This chart plots daily token volume against monthly cost. Centralized APIs and self-hosted AI intersect at exactly 2 million tokens a day. Below this, APIs are cheaper. Above it, recurring API costs aggressively outpace the operational expenses of self-hosting. To operate efficiently past that breakpoint, you can assemble an AI sovereignty stack. This involves composing protocols across 5 distinct layers: compute, data, model, inference, and coordination. Achieving sovereign AI means taking on technical complexity to eliminate reliance on a central provider. It is an operational choice dictated by your scale. This diagram shows the 5 layers of the stack. The bottom layer is compute. If you don't control the physical hardware processing your workloads, every other layer sits on someone else's infrastructure. Akash Network runs a reverse auction model that drops H100 GPU costs to roughly $2 an hour, an 85% saving over AWS. However, Akash currently operates with only 69 providers, meaning you trade reliable scale for lower costs. Render Network attracts genuine enterprise workloads and high liquidity, but it operates a permissioned, centralized system with a freedom score of only 32 out of 100, and it is still pivoting into the AI space. Then there's IO.net. They market a network of 327,000 GPUs, but the audited reality shows that after a massive Sybil attack, only 2%, roughly 6,700, are actually verified and active. Compute is currently the most production-ready layer of the stack, but to capture these cost savings, you have to forfeit the managed services of a traditional cloud provider. The second layer, data, is the hardest problem to solve. It requires obtaining massive training sets while protecting sensitive user inputs. Look at the trade-offs here. Grass acts as a bandwidth scraper where users bear the legal risks of exit nodes. Vana offers genuine cryptographic data sovereignty, though the financial value of an individual's data remains very small. Ocean Protocol offers compute-to-data technology that keeps raw data locked in place while algorithms travel to it. While the tech is mature, the protocol is currently hampered by a governance crisis and active litigation. This graph details the third layer, models. Having access to open-source model weights is a prerequisite, but you still need the hardware capacity to train and run them. QLoRA has democratized this process. It reduces trainable parameters by 99%, taking the cost of fine-tuning a 70 billion parameter model from $360 down to roughly $10 using consumer-grade hardware. While securing truly sovereign data is still a systemic hurdle, the models themselves are now economically accessible to almost anyone. The fourth layer, Inference, acts as your privacy shield. It determines who can see your prompts and sensitive healthcare or financial data. Venice uses privacy by policy. They don't store prompts, but GPU providers could still see them in plain text. Follow provides hardware-enforced privacy through TEEs, which is fast and compliant, but it requires you to trust silicon manufacturers like Intel and AMD. The final layer is coordination. This is how distributed participants discover and reward each other without a central authority. Bittensor handles massive daily token volume and real AI workloads. However, it currently has a stake weight problem, where early wealth often dictates network earnings more than the actual quality of the AI produced. Morpheus is the only protocol in this space with a genuine fair launch and zero insider allocation. This protects against rug pulls, but the trade-off is thin market liquidity and early-stage agent capabilities. Because no protocol achieves perfect sovereignty yet, you have to choose between trusting hardware vendors for privacy or accepting skewed economics for network liquidity. This table helps you match a stack to your scale. You can align specific protocol combinations directly to your budget, your threat model, and your token volume. The entry-level stack is for individuals. Running a model like Llama 3.1 locally via a Llama provides high sovereignty for under $200 a month, limited only by your own hardware's VRAM. For small teams, a professional stack combining Akash H100 spots, Vana TEE Inference, and Bittensor coordination allows you to run complex 70 billion parameter models for $2,000 to $4,000 a month. The enterprise stack uses a multi-provider Akash cluster and Ocean protocols to manage sensitive data. It costs $40,000 to $100,000 a month, trading some decentralization for guaranteed uptime and compliance. Many builders find the most success with a hybrid approach. One fintech case study showed an 83% cost reduction by routing non-sensitive queries to cheaper APIs while keeping sensitive workloads on self-hosted infrastructure. The technology for AI sovereignty is now available for deployment. While trade-offs in hardware trust and network liquidity persist, the degree of independence you achieve is a direct result of how you choose to build.